All right, let's take a look at finding the derivatives of logs and exponentials. The good news is this stuff is actually pretty straightforward. These are pretty easy derivatives to go through and calculate. So e, being this very special number, actually has about the easiest derivative that you can come up with. So remember this d over dx, that means you're taking the derivative with respect to x. So what we're doing is we're taking the derivative with respect to x of the function e to the x, and as you can see, what you get back is e to the x. So e to the x is its own derivative, right? Which is, again, about as easy as it gets, right? The derivative of e to the x is e to the x. Well, what if you have a different base, right? It doesn't work the same. The derivative of 2 to the x is not 2 to the x. There's a little bit of an adjustment factor you have to take care of, but it's not very difficult. The good news is a lot of the exponential functions we end up taking the derivative of are some form of e to the x. So that makes it a little bit easier. But if we want to take the derivative of b to the x, that's going to be b to the x times the natural log of b. So still not very difficult, but usually we're going to be in this some version of this uppercase anyways. Then you have your logarithms. And if you look, the derivative for logarithm, pretty easy too. So d dx, that means we're taking the derivative with respect to x of natural log of x, and the derivative is 1 over x. Okay, so pretty straightforward one to go through and do. If you want to take the derivative of a log with a different base, you can do that as well. You just, again, end up with this this little bit of a conversion factor of natural log of b that you have to remember. But again, the most of the logarithms that we take the derivative of will be some form of natural log. We'll do a few of the other ones, but most of them are going to be this easiest form to deal with. So that's convenient. So let's say we want to take the derivative of something like f of x equals 5e to the x plus 7 natural log of x. So remember, we have this property that says that we get to just focus on each term at a time. So I can focus on the derivative of that first term, then I can focus on the derivative of that second term. So if we go ahead and take a look, the derivative of 5e to the x, well, the derivative of e to the x is e to the x, so we just end up with 5e to the x again. And then we end up with the derivative of 7 natural log of x being 7 over x. Well, how does that work? Well, the natural log of x piece, when you take the derivative, this becomes 1 over x. So 7 over 1 times 1 over x becomes 7 over x. So all by themselves, exponentials and logarithms are actually really easy to take the derivatives of. Now we're going to get into more complicated functions later where we have more complicated versions of logs and exponentials. But overall, the basic tools you're going to use for taking the derivative of those is pretty straightforward.